everyone. Welcome back to SAT Math Question of the Day. Here's our question. Please try it, pause the video, come back, and we'll do it. Rectangle X has a length of 12 centimeters and a width of 2.5 centimeters. Right triangle Y has a base of 10 centimeters. The area of triangle X is 3 times the area of triangle Y. What is the height in centimeters of right triangle Y? So it looks like a two-step problem. So it sounds a little harder than a one-step problem, but it's a two-step problem. This is a calculated section, so that could be handy. So why don't we just calculate the area of triangle X, even though we don't really need a calculator, but it's 30. Okay, now, the area of triangle X is 3 times the area of triangle Y, so triangle Y is smaller. So triangle Y's area is 10 centimeters squared. Its area is 10 centimeters squared. And they're asking us what is the height. The area of triangle X is 3 times the area of right triangle Y, which means that triangle X's area is, rectangle X's area is 30 centimeters, so that means triangle Y's area is 10 centimeters, right? Because rectangle X is 3 times right triangle Y. So, now we want to calculate X. My God, there's so many X's, it's horrible. So let's change this to an H. So we want to try to calculate the height of the right triangle Y. We know the formula for the area of a triangle is 1/2 the base times the height. And we're lucky enough that we know in a right triangle the base and the height are very easy to see. So the base is 10 and the height is what we need to solve for. And we're told the area must be 10. So we want to solve this equation. 1/2 10h is equal to 10. 5h is equal to 10. H would equal to centimeters. Oh, they say in centimeters. Okay, fine. So it's a two-stepper. Not that each step isn't that hard, but you got to take it slow. And you also have to be careful to go down by a factor of 3, not up by a factor of 3. So it has a word problem feel to it. That's easy to get that wrong. What do you think, Seth?
I agree.
Yeah. I mean,
Yeah,
you just got to plow through it step by step.
Yeah.
And be careful. I think I don't know. I forgot if they give you the area of a triangle on the test. I think that I'm not sure if they do, but you should know what the area of the formula for an area of a triangle is, and the same thing for an area of a rectangle.
Yeah.
Area of a rectangle is length times width. Area of a triangle, we just did, is 1/2 the base times the height. So, you're awfully quiet today, Seth.
I just got up.
Oh, okay.
Yeah.
Okay, that's fine. So, by the way, today's Throwback Thursday, so after we do this, we're going to do a Throwback Thursday question. Yeah, you got to get ready for that. Okay, I guess we could go through our 4 questions. What would be different? How would this question be different from a school test? Not really, except school test probably would not be a multiple choice. That leads it a multiple choice question. The multiple choice question doesn't really help you here. I mean, you could do it backwards. You could just solve. You could do that. You could literally calculate each area of every triangle, given the answers, and see if it's 1/3 the area of 1/3 of 30. You could certainly do that. 2 times 10 is 20. Half of 20 is 10. Yeah, you could do that. You could just go through all the different answers and check and just back solve. Calculator section, well, I use the calculator for 12 times 2.5, but it may take more time to open up the calculator on the digital SAT than it would take to actually do that. If you wanted to do 12 times 2.5 without a calculator quickly, it's 12 times 2 plus a half. Right, yeah, 12 times 2 plus a half. This is 24 and this is 6, so you get 30. So you could break it up using the, sort of, nice, that's going to say when I say undistribute. What do you say? What do you say when you can't say undistribute because undistribute is not a word. But what would you say if when you take the 2.5 and you break it up as 2 plus a half? What do you call that process?
I don't know. Decompose?
Fine. Decompose. Yeah. Okay. And the main idea of the question, well, they certainly are expecting you and they want to see if you know how to apply the areas of a rectangle and a triangle, and also how to read a question to make sure you read it in the correct direction. You may actually want to make it, put some physicality to it, like make a really big rectangle. Like you really, really can feel the problem. Make a really big rectangle and make a littler triangle. And that way you can see exactly what's going on. That's not a bad way to make sure you read the question right. And you have to know how to set up equations, and you have to be familiar with what I sometimes call the backwards question, which is where they give you the area and you have to solve for something inside in the formula. Anything else, Seth?
No.
No? Okay. So pretty standard. Okay, so let's move into Throwback Thursday. We have a question from, I don't know, a book from 20 years ago, 25 years ago. It feels the whole question feels very different from anything you'd see today. There are two questions, 18 and 19, so maybe we'll do both since we're here. So these are questions from a test from 20 years ago. The test didn't really test as much back then. Well, now, post 2016, the test really tests what you learn in school. You never see things like this in school, but let's do it anyway. Okay, that's why it's an older test. Bracket X is defined as 1 less than the number of digits in the integer X. For example, bracket 100 is the number of digits 3 minus 1 is 2. If X is a positive integer less than 1,000,001, then X is at most. Well, it doesn't seem, on the scheme of things, it doesn't seem that. If we have to count the digits, 1, 2, 3, 4, 5, 6, 7 digits. So, bracket this thing is 7 minus 1, which would make it 6. I don't know. Is there something else to this problem? Or is it that straightforward? Oh, it's less than. It's less than. It's less than. So this has to be a 0. Right? Not equal to. That has to be a 0.
That's because they're asking for the maximum value of this funny function of X. Yeah, so you pick and so the bigger the number, you could maximize you could increase the function by making the number bigger.
Right.
Always increase the function by making a number bigger.
Right.
Because reducing the number of digits always reduces the size.
Right.
Increasing number of digits, except when you're assuming you're writing your digits so that the first digit is always non-zero.
Right.
So the highest order digit is non-zero. Yeah.
So it seems like that's the answer.
Yeah.
Okay, well, we'll check it. Okay, if X has 1,001 digits. Wow. Okay, so X is not 1,001, but X has 1,001 digits. Oh, okay. Well, if X has 1,001 digits, then it's 1,001 minus 1.
What is it?
Oh, this thing. So we have to, so this is...
No.
Then what is the value of this thing?
Okay, this is a tricky.
You have to do this 3 times. You have to do this thing 3 times.
Well, yeah.
Yeah, you have to do this. You have to do this. Now, I can't believe that they didn't put 1,000 here as one of the answers. Okay. So if... Oh, maybe it can't be determined. Wait. That's a toughie, right? So let's just see. Let's just plow through. If this has 1,001 digits, then the first hit of it is equal to 1,000. Now the second hit of it is equal to 4 minus 1, which is equal to 3. And then the third hit of it is 1 minus 1, which is equal to 0. So it looks like the answer is either C or E. Because there may be some weird thing about X having 1,001 digits. Well, maybe not. Maybe there's no... I mean, if they're telling you the number of digits, they're not telling you the number, they're telling you the digits, and that's exactly what the formula uses. So, seems like that would be the... seems like that would be the answer, wouldn't it?
Yeah.
Seems that
way. Well,
I
had a little worry that what if one less than the number of digits is negative, but that can only happen when the number of digits is 0. But no number has number of digits equals 0. Presumably, the 0 number has 1 digit.
Yeah.
Right?
Right.
Would 0 have 1 digit?
Yeah. Yeah, 0 has 1 digit. Yeah. And does this apply? What about negative numbers? If this...
Well, they're talking about... Well, this problem doesn't... Yeah, this problem concerns the definition of digits, right?
Right.
And they don't tell whether,
so they don't have to worry about that. You don't have to worry about
presumably it's the numbers on the SAT. The SAT, unless they tell you otherwise, numbers are expressed in base 10.
Right.
All numbers are written in base 10 in the SAT.
Right. Yeah. So it seems like C is the answer. I would be 99% sure. I would not be 100% sure knowing the SAT. That you never know what thing that I don't know, trick, what subtlety that maybe we're missing. So, okay, and then what's the answer to this? 6? So, this is worth going to the answer book to see whether we really got these right. So, the answer book is, this is section 2, number 18, B. Okay, section 2C. Yeah, great, we got them both right. Well, we don't know if we got them right, but we got them. Our answers agree with the answer book to this old book. What used to be 50 cents now. Yeah. Okay. So you can see it really has a whole different feel from a modern post-2016 question. But it's worth looking at it. Okay, so I think time to wake up.
Yeah.
So Thanks for watching, everyone. I'm Joel. I have a PhD in mechanical engineering. My brother Seth has a PhD in math from MIT. He's been teaching computer science for many, many years at SUNY Albany. He's now retired, and he just woke up. And we're here to hopefully give you approaches and insights on how to do math SAT questions. We try to do one question a day. On Thursday, we do a question or two from a older test. And we hope that our different approaches our day with different ways of thinking help you. We look at the problems in different lenses, like you should try to get good insight into a better insight into all the problems. And you should go and do all the practice questions the SAT people give you on the digital websites, the digital website Blue Book. And whatever topics you're not sure about, you can go to Khan Academy, and they offer free practice on every topic, like about 20, 30 questions on every single topic to practice on and to learn from, and just learn from your mistakes and just recognize the material you don't know as well and study that more. And of course, be careful for stupid mistakes. So that's about it. Please comment on our videos. We take all our comments very seriously. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. Anything else, Seth?
No.
No, that's it. Okay, great. Okay, everyone, have a great day. We'll hope to see you tomorrow. Bye-bye.
Bye-bye.